All right, we're going to apply derivatives here. So it's more practice with taking a derivative, but not just taking a derivative to take a derivative. We want to find the equation of the tangent line. So we know that at any time we want the equation of a line, we need two things if we want the equation of a line. We need the slope, and we need a coordinate, a point. If we have these two things, we can write the equation of the line. So, coordinate, we'll start there. To get the coordinate, that's relatively easy. We already have an x value. X is equal to 4. So, all we need to do is take that and plug it into the equation. If we plug 4 into the equation, we will have our y value. So, y is going to end up equaling the square root of 4 plus 1 divided by the square root of 4. The square root of 4 is 2, so this becomes 2 plus 1 over 2, which is 2.5. I'll write that with a decimal because it ends 2.5. So we at least have our coordinate. Our coordinate is 4, 2.5. We have 2 out of the 3 things that we need. We have our x value and our y value, which makes up the coordinate, and then we just need the slope. To get the slope, we're going to need the derivative. Derivative gives us the equation for the slope at any point, and so if we have the derivative, we will be able to find the slope specifically at our coordinate at x equals 4. So what I need to do, I don't have a specific rule for square root because square root doesn't need a specific rule. A square root can be written as a power. Anything that's in the denominator can be written as a power. And so we can rewrite our equation. Instead of y equals the square root of x, this is something I expect you to know coming into class, we can write the square root of x as x to the 1/2 power. We can write 1 over the square root of x as x to the negative 1/2 power because the square root is in the denominator. That is something that I expect you to know walking into this class. This will allow us to take the derivative simply using the power rule. So y prime, the derivative, is going to be y equals x to the 1/2 power. The 1/2 becomes a multiplier, so we're going to multiply 1/2 times x, and then we don't want to forget we have to subtract 1 from the power. Subtracting 1 from 1/2 will give us negative 1/2. And then we have our second term, so plus, same deal. That exponent becomes a multiplier, so we're going to multiply by negative 1/2 x, and then we want to subtract 1. Be careful about subtracting 1. Negative 1/2 minus 1 is negative 3/2. There's your derivative. There's nothing more to do with that. Don't bother rewriting it as square roots anymore. In fact, anytime you see square roots pretty much forever in this class, you're going to want to write it as exponents and leave your answer as exponents. Don't go back to radicals. And so we have y prime, our derivative, is equal to 1/2 x to the negative 1/2 plus negative 1/2 x to the negative 3/2. But we're not done. That's just the derivative. We need to get the slope at a specific point. In this case, we need the slope at x is equal to 4. So, to evaluate that, I'm going to find my slope at x equals 4 by plugging 4 in for x. So I'm going to have 1/2 times 4 to the negative 1/2 plus negative 1/2 times 4 to the negative 3/2. I expect you to be able to evaluate this without too many issues. 4 to the negative 1/2 means do the square root of 4 and then flip the fraction 1 over the square root of 4. So the square root of 4 is 2, so that becomes 1 over 2, which is 1/2, and when I multiply with the 1/2 that's in front of it, I get 1/4. 4 to the negative 3/2 power. A negative 3/2 power, again, means it's going to be 1 over 4 to the 3/2 power. The 3/2 power, the half, the 2, means take the square root, so the square root of 4 is 2. The 3 means cube that. 2 times 2 times 2, that's 8. And then the negative means reciprocate that, make it a fraction, so instead of 8 over 1, that is 1/8. And then when I multiply 1/8 times negative 1/2, I will get negative 1/16. I expect you to be able to handle that without too many issues, because that is something you did back in Algebra 1, Algebra 2. So we should be able to handle that. Now we can just put these together. These are just fractions, no big deal. If you get a common denominator, this will work out to be 3/16. That, again, is your slope. And so now we have the key pieces of information that we need. We have our coordinate for 2.5. We have our slope of 3/16. We're mixing fractions and decimals. It's nothing that I really like, but it's doable. It's fine. I accept it. It's not that big of a deal. And so now we can write the equation of our line. Y minus our y value. Our y value is 2.5. Equals m. Our m is 3/16. Times x minus our x value. Our x value is 4. This is the equation of the tangent line for the equation y equals the square root of x plus 1 over the square root of x at x equals 4.